繋がった。よかった。皆さん、こんばんしょん。ロケット系Vtuberの宇推くりあです。ちょっと待って。もう打ち上がっちゃうんだけどさ。うまいこと繋がらなくて。配信ギリギリになっちゃった。ではでは、始めていきたいと思います。Vega-Cちゃんの打ち上げですね。あとね、1分ぐらいです。いきなり打ち上げから始まっちゃうけど、まあそれでもいい？リアいつもそんな感じだよね。ってことで、いきます。はい。こちらはですね、フランス領ギアナでございます。フランスではありませんね。場所はね、フランスではなくて、フランス領ギアナです。ちょっと待ってね。音声入ってないから音声入れるね。これで音声入るかな？何も言わなくなっちゃった。
À tous de DDO. Attention pour le décompte final.
危ない危ない。うまいこと言ったわ。よかった。はい。ということで今日はこれで
9, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage P120. Décollage. Propulseur nominal, début du basculement.
雲つぼやー！雲が低いわー！
Propulseur nominal.
雲つぼやー！雲つぼった。
Pilotage calme.
雲出た！ 飛んでる！
Trajectoire nominale.
出てきた。めっちゃ綺麗。うわ、すごい！
Acquisition Saint-Jean.
さあ、皆さんに質問です。質問ですというか。
Trajectoire toujours nominale.
このベガロケットちゃん。
Sunrise over the Amazon rainforest and Biomass has started its journey, blazing a trail on
La
board the
trajectoire est
Vega-C
nominale, le
rocket
pilotage est calme.
on its quest to understand forests just like the one it's lifted off from, on its mission for Earth and for our future. We can hear it flying over the...
Amazing pictures, and yeah, we can feel the walls
shaking here at the Jupiter Mission Control
Trajectoire nominale.
Center. He's telling us that everything is going well.
Yeah, so far it's perfect. We're lucky to see it so long. It's given the clouds we had at the beginning.
Getting some great views here from our cameras. Burning the P120 first stage here, which is getting us away from
La trajectoire est nominale, le pilotage est calme.
the gravity of our planet. The range operations manager there telling us that the trajectory is nominal and the pilotage, the piloting.
Yeah, control of the thrust, the orientation of the thrust as well. So it's nominal means everything's fine.
Good. Coming up
Début côte poussée.
on the separation of the P120 will be the first event.
La trajectoire est nominale.
Everything's going according to plan. Fantastic views.
Potentially we could see it from the cameras. It could be nice, yeah. Should occur in a few seconds now.
Indeed, this is the scheduled moment for the separation.
Séparation P120.
And it's just confirmed.
Allumage Z40.
So he's just confirmed that we've separated the
La pression est
P120,
nominale.
the
La
first
trajectoire est nominale.
stage. We've switched on the second stage, the Z40. Everything's going normally. And Z, what does that stand
Z
for?
is for, yeah, Zephyro, it's an Italian name for a type of wind. Because I guess it's a bit windy when you're on
Trajectoire du
board
lanceur nominale.
such a booster.
Look at that. Fantastic. We're seeing it. We're 3 minutes and 11 seconds into the launch, and we can still see it with our cameras, which is very exciting. So we've got clear skies here at the Ghana Space Center.
Amazing, yeah.
We had several weeks of rain and suddenly it's been very clear
La
and
trajectoire
beautiful.
du lanceur est nominale.
He's telling us that the trajectory of the rocket is normal.
It's perfectly as planned.
And of course the fairing, which is where our satellite is
今回は
encapsulated at this
ベガ C の4
point,
回目の打ち上げとなります。
Samuel, is the nose cone, if you like. We saw it before
La
the launch.
trajectoire est nominale, le pilotage est calme.
And
It has multiple.
it's got a number of jobs, hasn't it?
Yeah, exactly. Yeah. It basically protects biomass from a number of environments. First, of course, the Guyana environment, the rain, the dust, everything. But also at Liftoff, we have when we fire the booster, there is quite a high acoustic vibration environment. Then the fairing is used to damp it, and as well to
Trajectoire nominale, pilotage calme.
as we go through the atmosphere, it helps reducing the heat load generated by the friction with the atmosphere or the vibration. So it's quite a clever piece of hardware. Yeah.
Very important, and you can see it at the front of the rocket there, the sort of bulbous section. Right, we have now the scheduled moment to separate the Z40 to jettison that.
Séparation Z40.
So we just confirmation that the Zefiro 40 stage has been separated.
And
Allumage Z9.
And
we've switched on the engine of the Z9, and we've also
麦こんな風に
Waiting for
そんな軌道で変わる
of
の
the
すごい
fairing jettisoning.
Séparation des coiffes.
And we have.
そうグイって変わって今
So we can see our satellite for the first time. Samuel, why don't you explain to people what we're looking at here on these computer-generated images?
yeah, on the left of the screen, you can see on the right,
Trajectoire
biomass
nominale.
passenger with, of course, its radar and solar panel folded. It's
なんかまた
attached to the
良くなったな、
what
UI.
remains of the launcher,
かっこよくなってるよ、
which is
UI.
rather small as
どうだったっけ？
compared to what was on the pad, through the
全然
adapter, this
アスペクト
black
狂って
cone,
ない
and
し
then you have the upper
め
stage,
ちゃくちゃいい
which is
これもわかりやすい
a tiny, a slice, a white slice of the launcher, and on the
La
left,
trajectoire du lanceur est
若干
nominale.
低いねこれ
the Zefiro 9 stage, which is still thrusting our passenger into space.
And of course, once biomass is separated from the mothership,
Look,
it'll
Aria,
unfold
you're gonna
its
take
solar wing. It has one solar wing made up of 4 solar panels. And of course, it's amazing. Great big reflector, which looks like a huge space umbrella.
若干やっぱなんか低いように見えるけど
So quickly, let's just explain to people what we're looking at on the screen. So we've got the 3D images, which are computer generated.
Yeah, and they correspond to the plan.
La pression chambre est nominale, la trajectoire est nominale.
It illustrates what the
フランス領ギアナの話
launcher
しましたけど
plus biomass
そうここです
behavior should be in space, the
Oh,
orientation towards the sun or
ア
towards
フ
the
リ
earth, for
カ
instance.
アメリカ
Of
アフリカ
course,
じゃ
the
ないア
altitude,
メリカ南
the different stages separation as we saw, and of course the
言い方
the real orientation and firing as we see here.
You can see on the left side of the screen are the various events that as they happen, and then on the right-hand side of the screen the trajectory, and we also have the altitude. At the moment we're 663 kilometers
Trajectoire
high.
nominale, pilotage calme.
263. Yeah.
Sorry, it's 263.
Yeah.
We will be getting closer
Exactly.
to 600
Not yet.
And our distance is our distance from the pad. If you were to draw a straight line across our planet, and look at that speed, we are travelling, Samuel, at 7.53 kilometers per second.
This is quite fast, yeah. This is roughly, 8 kilometers per second, just for people to have an idea. 30 times the velocity of a commercial aircraft, so it's fast.
Séparation Z9
It's
confirmée.
about 28,000 miles per kilometers per second.
Per hour. And here is, we had just confirmation of the separation of the third stage, the Zefiro 9.
方向に
Indeed, and we can
Acquisition de
see
la télémesure par la station Bermude.
there he's announcing that we're picking up the signal at the Bermuda tracking station, which you can see there on the globe. Bermuda, of course, in the northern Caribbean.
Orbite du Z9 correct.
I'm sure it's all very sunny as the sun rises there. Very pleasant weather, I'm sure. Checking in there at Bermuda and saying hello to the teams. So our flight path takes us, north?
Yeah.
Up over the North Pole?
Exactly, yeah. We'll fly after the Canada, we'll fly over the Arctic and then back down over Southeast Asia and to the west coast of Australia, where we will separate biomass.
Début de la manœuvre d'orientation pour le premier boost à volume.
So he's saying we are orienting doing a set of maneuvers to orient correctly the launcher to fire the upstage Avon Plus, which should occur in a second or two.
1回目のブーストを行っていきます。
Allumage de l'Avon.
So we have confirmation that the Avon Plus upper stage has switched its engine on, and that's an important moment, an important milestone. We've really now started the next phase of the journey because the Avon Plus is a little bit like our orbital taxi driver. Its job is to deliver our passenger to its drop-off point in space, and that's a very important job.
Yes, indeed, and it's the Avon Plus job, as you said, to deliver biomass exactly on the right orbit, in the correct orientation, and to do that, we need to perform with this upper stage precise set of maneuvers, and we'll see two firings. This is the first firing, and we'll have another one later in the mission, and this will enable to reach the separation orbit, which is circular at 670 kilometer altitude in about 49 minutes.
Fin de visibilité Galio. Trajectoire nominale, propulsion nominale.
So we've gone out of the range of the Galileo tracking station. That was the tracking station here at the spaceport, and everything's going well. Big space projects like Biomass involve hundreds, sometimes thousands of people pulling together to make them happen. They involve brain power, teamwork, lots of problem-solving skills.
And possibly lots of coffee cups as well, or tea.
Lots of cups of tea in this case, yes, because Biomass has been designed, built and tested by the European aerospace giant Airbus Defence and Space, and all of that's been done in the UK.
And they are what we call prime contractor, so it's like they are conductor of an orchestra.
Propulsion nominale de l'Avon, pilotage calme.
It means they manage a group of companies and suppliers. Each of them play a super important role, and we have many industrial teams from Europe, but as well from US or Canada, which were involved in delivering hardware for Biomass. And in particular, as you mentioned, the satellite platform was assembled in the UK, indeed.
In fact, I was lucky enough to see it because I was filming there a little while back, and it was really exciting to see Biomass in the clean rooms taking shape. Big shout out actually to my fellow compatriots in the UK, Airbus in Stevenage. So let's just check where we are in the flight. We are climbing
close to 300 kilometer altitude and 3,000 kilometers.
Trajectoire de l'Avon est nominale.
So trajectory is perfectly on the target. We are running gently the propulsion of the Avon Plus, consuming propellants.
And we're coming closer now to picking up the signal at the Gatineau tracking station. You can see it there in Canada, the northeastern coast of Canada.
Acquisition de la télémesure par la station Gatineau.
He's just confirmed that we've picked up the signal there. It's a bit like a relay race, isn't it?
Exactly, yeah.
Handing the baton from one tracking station to another.
Yeah, we want to be sure to have contact with the launcher during this phase while propulsion is active to receive the parameters.
Pression nominale des réservoirs, le pilotage est calme, la trajectoire est nominale.
Everything's going normally. So the rocket's talking to us, it's sending its signal back down to the tracking stations, and they then transfer that information to the telemetry team here at the spaceport. We call them the CVI in French, or the Quick Look Telemetry Team. And we can see them actually in the bottom right of the screen there. Our colleagues, your colleagues there, Samuel, they're on a hilltop, aren't they, just outside the spaceport?
Yeah, very close to the spaceport on La Montagne des Pères. And they are actually, as you said, receiving the major flight parameters from the launcher.
Nominale de l'Avon.
All along the flight, thanks to these antennas, which are located on the
Il reste 3 minutes de propulsion de l'Avon.
On the path, and it's a bit like the doctors who are checking the health, monitoring what's happening on board, checking everything's fine as expected. And you can see here my colleagues Michael Krebel, who is in charge of the team, and also Armel Giral, together with Avio and CNES colleagues. And this is, as we said, possible thanks to the different ground tracking stations located first were in French Guiana, then in Bermuda, then in Canada, and last one will be in Australia, as we mentioned.
Now, one of the features of the Avon Plus upper stage is that it can restart its engine again and again. We have another team here in the Colifero in Italy.
Yeah, indeed. There are teams from Avio, the rocket manufacturer, and they are checking from Italy that the launcher behavior is fine, analyzing the data.
À décart en altitude, trajectoire nominale.
There are people from different teams, such as propulsion, structure, control,
Le lanceur est mis sur orbite.
and they are available and ready to jump if needed as a support team, so it's very useful.
And indeed, as you say, they're the manufacturers of the rockets, so it's very useful to have them there and to have as many people on the job as possible. Indeed, as I was saying, one of the features of the upper stage is that it can switch its engine on and off, and that's actually very important. Why is that?
Yeah, it's very key because it's a major asset of this upper stage because it makes possible to take different passengers, like you say, like a space bus, to two different passengers to different orbits, but in the same launch. So this is really key. And with this upper stage Avon Plus, we can fire it up to 8 times, and this is much more than the previous 5 on little sister Vega. And so it's very helpful to deliver several satellites on typically 3 different orbits we can reach with Vega-C.
1 minute de propulsion de l'avant.
On the same
La
mission.
propulsion est nominale, trajectoire nominale.
So it's really a key asset for our customers indeed.
And it means that you can take pretty well any satellite to any orbit, and that's very important, that level of flexibility. And we're getting ready now, the Avon upper stage is getting ready to switch off its engine. How does it know when to switch it off?
In fact, this is based on its initial position, which we feed the launcher with on the pad, and then it has clever instruments along the flight, computing where it is and how it's oriented, what's its velocity all along the flight, so it knows precisely where it is and when to stop it, which should occur. So
we are 329 kilometers above our planet. We have now gone out of range of the Bermuda tracking station, and we're being tracked by Gatineau, getting ready to switch the engine off.
Propulsion nominale, pilotage calme.
For the confirmation
Extinction de l'étage avant.
And we have the switch off of the upper stage engine now confirmed, so that's really good. Why now? Why do we switch it off now?
Par l'étage avant correct.
So it's just saying that when we stopped the engine, as I was saying, we were exactly on the point we wanted to be. So this is really good news. And why do we stop it? We stop it because we are climbing to just below 700 kilometers, and we'll do it in 2 steps. So here, this is the first step, and we have reached the target for the first step. So we just stop it, and it's all very normal as planned.
Now, today's launch is the result of years of collaboration across many teams, and we've been talking to some of them. Let's hear from them now.
Je suis chef de mission Ariane Espace pour la campagne de lancement de Biomass, un satellite scientifique de l'Agence spatiale européenne.
At ESA, we are the system architects of the mission. That means that me and my team, we are responsible that the satellite is being built, that the algorithms for data processing are there, and finally that we have a launcher.
La responsabile di campagna ha il compito, conoscendo tutto il sistema e avendo una visione un po' di tutto il sistema, ha il compito di identificare eventuali impatti e a gestire la riprogrammazione delle varie attività.
Lo importante para poder desarrollar y construir un satélite es la gente, es lo más importante, y además tener un buen equipo. En Biomass todo el mundo ha estado involucrado desde el principio y me parece que tenemos un buen equipo de AIT y de diseño.
Chaque lancement est spécifique, chaque campagne de lancement est spécifique. Donc toutes ces spécificités doivent être prises en compte par le chef de mission dans son planning de préparation. Il faut évidemment faire preuve d'une adaptabilité importante tant au niveau technique qu'au niveau relations avec les différents industriels. Donc il est important de les écouter et de bien leur faire comprendre toutes nos spécificités pour que la campagne de lancement se passe au mieux et que la chronologie de lancement se passe également au mieux.
Le giornate di campagna non sono mai tutte uguali, sono molto diverse l'una dall'altra, ci sono sicuramente degli appuntamenti che sono sempre gli stessi, sono dei momenti di confronto tra tutti i team di campagna e sono dei momenti ai quali non si può rinunciare, a cui devo partecipare.
Durante el lanzamiento nosotros los eléctricos vamos a estar justamente aquí detrás encendiendo el satélite por última vez y me han dado el gran honor de poder ser la última persona en encenderlo y además durante las últimas 30 segundos vamos a poder ver que todo funciona perfectamente.
Biomass is a science mission, an Earth science mission. It is an instrument that has never been flown before. Therefore, we had to face a lot of technological problems in its development. We were also hindered by the fact that we were in the middle of the COVID crisis when the most people should have been in the laboratories. And finally, to mention as a challenge is that the instrument cannot be tested on ground and we have to rely on tests and analysis, and we will only see the final outcome once we are in orbit.
À Jupiter 2, à côté du DDO, on est là pour la coordination globale. Le DDO s'occupe de la partie
Pleine visibilité de la station Gatineau.
La base de lancement avec
le
toutes
trou
les
TM
stations
attendu
poursuites qui
est d'environ
suivra
32
le vol
minutes
lanceur
et
jusqu'à
25
l'injection
secondes.
satellite. Et le chef de mission est à côté de lui pour lui transmettre toutes les informations venant de la charge utile, donc du satellite, et toutes les contraintes qu'ils amènent, évidemment, pour aller jusqu'au lancement.
Good to hear from the teams there. Now, once the upper stage delivers biomass onto its orbit, the teams at the European Space Operations Centre, which is in Darmstadt in Germany, will take charge of flying their satellite.
Yeah, and first biomass should call home, then it will unfold its solar wing and start all the process of being tested before actually it can begin its job of scanning our forest, which should start in 6 months from now.
Indeed. And the teams at ESOC operate all the European Space Agency's satellites. That's more than 90 of them over the years. And they also take care of ESA's network of tracking stations. They provide world-class expertise for flight dynamics and mission operations. And it's also home to ESA's space safety program, so it's a busy old place. Thomas Ormiston is a spacecraft operations engineer, part of the team flying the satellite, so he's one of the people in charge of flying biomass today. Let's go to Thomas now.
And hello, welcome to Mission Control here in Darmstadt, Germany, where the team are calm, sitting back, enjoying the ride for the time being, as we carry on the journey of biomass to space. They're all getting ready for that moment we're hoping for a bit later on, where we'll pick up the signal. But for now, we can enjoy standing here, and I'm here very happy to be joined by biomass mission scientist Bjorn Roman, who's going to tell us a little bit more about what biomass is going to do. So thank you, Bjorn, for being here. It's your baby. How are you feeling having seen that spectacular sight?
Yeah, spectacular launch, Thomas. It was great to see it from here. We're also joined here by a lot of people from the science team. We've been waiting for this for years, and of course waiting now for the spectacular things that are to come after the launch.
Absolutely, and I saw the emotions on people. It's quite a moment here, and there's still more moments to come. Now, tell us a bit more about this. One of the key goals of biomass is to study the role that forest biomass plays in the carbon cycle. How is the data from the mission going to help fill in humanity's understanding of this?
Yes, Thomas. A very good question. The main science question of the biomass mission is really to try to unravel the main unknowns that we have in the global carbon cycle. As people know, most of the actual CO2 emissions that are going up in the atmosphere are coming from the burning of fossil fuels, but the remaining part is coming from land use change, and most of it can be attributed to deforestation. And this is and on the other side, there's of course as well then the actual sinks. About half of it, what we're actually emitting, remains remains in the atmosphere. About 3/10 is going back into the forest. So this is actually a very good thing. This is actually one of the few things where forests are known for. Is that actually there's a very natural way of capturing carbon, and actually the forests are growing from it. So it's actually a very, very nice thing. The remaining part is going into the ocean, and for the oceans actually it's kind of a bad thing. You get an acidification of the oceans, which is really detrimental for the ecosystems and biodiversity. On top of this, the biomass mission will especially look at the tropical forests, and this is exactly the areas where the
打ち上げ前に戻します。これがバイオマスじゃん。みんな見てくれ。このかわいいかわいい傘を見てくれ。かわいいだろこれだよ、バイオマスのかわいさは。この辺からいきます。What about
Take a closer look.
What about biomass? はい。地球を見てくれる子なんですが、森林とかね。
For thousands of years, forests have acted as the lungs of our planet, absorbing carbon dioxide, releasing oxygen, and sheltering an incredible variety of life. However, deforestation, climate change, and human activity are changing these essential ecosystems at an alarming rate. So how can we accurately gauge the extent of organic matter stored in our forests? The answer lies above us, in the silent, watchful gaze of a satellite. Introducing Biomass, a revolutionary Earth observation mission, set to change the way we see and study the world's forests. Biomass is part of the European Space Agency's Earth Explorers program, pioneering scientific missions designed to deepen our understanding of Earth's complex systems. Today, from Europe's spaceport in Peru, Biomass will embark on its journey aboard Vega-C. Weighing 1,250 kilos, this cutting-edge satellite will be placed in a sun-synchronous orbit, 670 kilometers above Earth. Its mission? To deliver the most accurate map of biomass distribution in Earth's forests. Equipped with a fully polarimetric K-band radar and a massive 12-meter diameter reflector, Biomass is the first satellite ever to carry a radar instrument capable of penetrating dense forest canopies to collect information on tree trunks and branches, where the majority of carbon is stored. Forests are among our strongest allies in our efforts to mitigate climate change. They store vast amounts of carbon, but the exact quantities remain uncertain. Rising temperatures, increasing CO2 levels, and expanding human activities are reshaping forests in ways we still don't fully understand. Biomass will provide the first ever global estimates of forest biomass and height. Over its 5-year mission, Biomass will systematically scan the entire globe every 9 months, delivering crucial data on forest structure, biomass distribution, and above-ground carbon storage. This is the missing piece scientists and foresters have long sought to improve climate projections. Governments, conservationists, and researchers will have access to reliable and consistent forest data, enabling them to make informed decisions that shape the future of our planet. By unveiling the unseen, Biomass serves as a storyteller for our forests, a beacon of knowledge in the pursuit of a more sustainable future. Because to protect our environment, we must first understand it.
Indeed, and that need to understand how Earth works as a system and how people are affecting natural processes is more urgent than ever. And Biomass is the 7th satellite in the European Space Agency's Earth Explorer science program to do just that.
Yes, indeed. And in fact, the Earth Explorer satellites actually collect information about all the complex processes of our planet. We can have several examples. Typically, the
こんにゃく畑食べてよ。改めてバイオマスのことを確認していくと、森林観測とか、それから、 山火事もあったけど、地球観測系ですね。そういう話、あと、二酸化炭素とかの話もキーワードになってるそうです。はい、バイオマスサテライト。ちょっとこれ翻訳して見てみますかね。ちょっと待ってよ。翻訳はだけバターじゃない。傾斜軌道に入れないんだろうって、なんで傾斜軌道に入れないか。傾斜軌道の方がいいような気がしたっていうことなんかな。ちょっとその辺聞いてみたい。傾斜軌道の方がいい気がしたっていうのは、職域植物ないから別にいらんないんじゃねってこと？なるほどね。そうね。特にどれぐらい意味があるかっていうのあんまり記述がないような気はするな。難しい配信してる。わーい、つみこちゃん来てくれてありがとう。難しいけど、なんか画面に映ってるものが難しいだけど言ってることそんなむずくないよ。なんかね、地球のね、森とかをね、見るね、衛星を打ち上げたん。そんな感じ。マジでそんな感じ。それだけ。終了って感じ。うんうん。わかりやすいや。そやろあとはなんかあるかな。待って。バイオマス衛星合成開口レーダー。森林の、なんだっけ。高さや構造の情報を収集する。それから砂漠の地下の構造とか。氷の構造も見るって書いてあるから、もしかしたらそういう意味では極域に意味があるのかもしれないね。で、地球全部のスキャンとか、マッピングをするって感じですね。砂漠の地下の地質って書いてある。これですね。これ、サブサーフェイスよりインデザート。氷を見れるのか。これ。アイスストラクチャーオブアイスシーツ。これ。表彰のアイスストラクチャー、構造が見られますっていう風に書いてある。だから極軌道が必要なのかもしれないな。もぐ。はい。ということで、まあ、世界の気象観測のための地球観測衛星でございます。はい。5年間にわたり観測を行うって書いてるので、いっぱいやってくれるんじゃないでしょうか。これね、5年間。ライフタイム5年間。そうなんだよな。数年ぐらいのもんなんだよな。じゃあちょっと他のところを見てみようか。今どこまで行ったんだろう。2回目の燃焼とかまだかな。まだかもしれないな。まだだった。じゃあちょっとバイオマスを見ていこうね。次のページ。ベガシーランチャー。キャンペーン。ステークホルダー。終了かな。じゃあ次、ベガシーランチャー紹介しましょうか。はい、こちらがベガシーランチャーです。イエーイ。ベガシーっていうのは、まあ、ベガ A とかベガ B っていうのが今いるわけではないんだけど、こいつはベガ C ですね。で、前にいたのがベガってやつがいました。何？氷見るのはリアの冷凍庫。はい。氷？リアの冷凍庫やばいかも。今はそんなでもないよ。まだ綺麗。そしてこちらがベガシーランチャーですね。ベガシーランチャーっていうランチャーっていうのはロケットを打ち上げるものじゃなくて、ロケット本体のことを紹介してるみたいですね。はい。で、1段目 P1201 ヨープロパルジョン。それから、 インターステージでしょ。ゼフィーロ40、アビオっていうね、ところが作っているゼフィーロ。はい。それから、ゼフィーロの9。そして AVUM。で、段数で言うと、P120C っていう1段目があって、2段目と1段目のつながりがここ。なんかさ、斜めになってるけど、この中にもう一個エンジンが入ってね、つながりがあって、ここにゼフィーロが入って、ゼフィーロっていう名前のロケットエンジンがモーターがあって、で、3段目がここ。ゼフィーロ9。で、4段目に当たるものがこの AVUM ってやつなんだけど、私の通りこいつは液体なので、何回もつけたり消したりすることができます。なので、今回この後にブースト2回目とかをね、予定していますよね。こんな感じ。これはずっと開発中だったんですけども、4回フライトになりましたかね。はい。1段目は個体なの？はい、1段目 P120C ちゃんは個体ロケットでございます。はい。しかもですよ、これね、アリアン6のロケットブースターに使われるために設計された個体ロケットモーターなんですよ。つまり、なんか似てることないですかね？なんか、個体ロケットで、もっと大きい別のロケットのブースターになるために開発された、これってなんか似てるような気がしませんか？コメント欄に説明を任したけど。イプシロンだ。すごい。みんな、やっぱ有識者ばっかりですね。コメント欄に走る方。実はですね、アリアン6っていうロケットがありまして、それがね、欧州の今一番、主力のロケットなんでございます。はい。その欧州主力ロケット、アリアン6についてるブースターと、共通の部分があるっていうのが、このベガ C の特徴でもあります。まさにそれは H3 ロケットとイプシロンの関係のように、H3 ロケットのブースターがイプシロンの第1弾に使われているものを使っているように、はい。同じような関係にありますね。それに、アリアン6と H3 も似てますね。液体酸素も、液体水素も使う関係でもあるし。よいしょ。よいしょ。アリアン6のページを開いて、それを見せればいいのかな？レガシーがうまくいってるの羨ましいなってコメントありがとう。そうだよねー。エプシロンがちょっと今正直止まっちゃってるようなものに近いからね。そうだよね。アリアン6のページに行きたいな。待ってね、アリアン6。エプシロン。アリアン6のことを紹介したいんだけど、どう紹介するのがいいんだ？コメント。よいしょ。一旦このウィンドウを消すね。後ろになんか別のあれが出てきた。はい。アリアン6オーバービューてってれー。ちょっと BGM 入れます。一層外国の試験場カレーとかした方がいいんでしょうか？いや、絶対ないよ。無理。絶対ない。絶対できない。多分ってか絶対できない。リンゴ、違う。みかんのこんにゃくはだけどそれだろ。費用や手間とかじゃないんだよね。技術は出せないから。国外に。持っていけないよ。輸出は、絶対ダメだわ。できないと思う。輸出規制もあるし。それに固体ロケットの技術は特に防衛と密接ですから。 あと爆発してるからね。そう、それもある。爆発してるのに、海外のロケットのところを壊すかもしれないの持っていけないよ。うまい。で、このアリアン6さんからですね、こんなロケットになってるんだけど、この下の、この横についてるこれね、これが結構、アリアン6と、あとイプシロンじゃなくて、ベガと、同じところをね、同じものを使っているっていうのが特徴ですね。これ、P120C ブースター。これがさっき言ったアリアンの P120 と一緒。レガシーの P120 と一緒。マジで見てくださいよ、これ。アリアン6が押してるのって、これなの。幅広いミッションに対応なの。これもどっかで聞いたことあるんだよな。これもどっかで聞いたことがある。つわれる。もうね、バチバチライバル。もうマジバチバチライバル。本当に。高さ60メートル。これも聞いたことあるんだよな。ね。ありますね。ありますよね。まあこんな感じでね。でっかいロケットが来たら、違うね。でっかい衛星が来たら、でっかい長いフェアリングを準備できます。重たいものが来たら、何個もブースターをつけることができて、どんなミッションにも柔軟に対応ができます。っていうね、感じです。あとは液体酸素と液体水素を使っています。しっかりね。ね、なんかね、見たことある。見たことあるぞ。そう。はい。まあでもこういうところと同じ、歴史を辿ってきた歴史がやっぱあったりするので、この歴史を紐解くみたいな配信をするの面白そうだな。こんなのがありましたっていう歴史をね。はい。あと、ローンチゾーンね。これは、日本にはない、海外のサイトを使っているっていうのは結構、ね、面白いかな。フランス領ギアナのヨーロッパの宇宙ところから、はい、打ち上げをします。A3 はサバルケットがあるから。そうだよ！サバルケット早く飛んでほしいんだけど CFP まだ？はい。これも似てるかなと。縦向きに組み立てるっていう。ねえ。こんな感じで、こういうロケットがいるんだよっていうのを知ってもらえたらとても嬉しい。ほい。以上。以上、アリアン6でした。うわ、なんだこれ。はい、これ、イーサのページでございました。あ、ちなみに、これ、バイオマス今回飛んでるんですけど、イーサのね、地球観測衛星なので、ヨーロッパで作ってヨーロッパで打ち上げているということになりますね。いろいろバイオマスミッションについていろいろ書いたりとかしてます。ブルブルしてる。ちょっと待ってね。危ない。バイオマス。いいさ、フォレストミッション。あ、フォレストミッションっていうの君。かっこいいね。 フォレスト。二酸化炭素もやっぱ書いてるな。副軌道だったら赤道の出る気ないのでは？ないっていうかむしろ、なくはないけど、開けてるっていう意味で、打ち上げ市場があるっていう意味ではあるけど、赤道にしてしまうと逆に手の手間になりますよね。あと今までのパイオニアかな、今まで先人たちをここに書いてますね。リアがコラボさせていただいたアースケアもね、ここにいます。アースケアちゃん、アースケアちゃんマジかわいい。グローバルカーボンサイクル。まあ、二酸化炭素の世界の動きとかをここに書いてるのかなと思います。土壌にあったりとか、何パーセントがこう飛んでってて、何パーセントがどこにあってみたいなことが書いてるみたいですね。そして森の役割。気候の感じとかね、そういう話をしているみたいですね。これこそ本当にカーボンサイクルの話ですね。CO2 が出て、それがどんな風に地球環境の中で回ってっていうのかな、受け継がれてっていうのかな、飛んでいってっていう感じになるのかなと。あとは宇宙からバイオマスフロムスペースマッピングをする理由は何ですかっていうのとかが書いてありますかね。P バンドの合成開口レーダー。まあ合成開口っていうのはかっこいいけど、意味は何回もスキャンというかこう進んでいって何回も重ねて合成していくよっていうそういう感じなので、衛星だと大体まあ合成開口レーダーになっちゃうよね。まあレーダーが積んであるよと思ってもらって OK。で、最低でも5年間あるので、なんか7、8回ぐらいは見れるって書いてあったね。式っていうのかな、1年の繰り返しを、はい、最低5回は見れるんじゃないかな。これか、リアこのページを全然見てなかったから。これね、氷の下も見られるってやつ。ビアンドフォレスト。フォレスト以外の話もしていくと、P バンドはディープイントゥアイスを見ることができますって書いてありますね。すごいな。氷の中も見れんだ。へー。お、かわいい。9年開発にかかりました。エアバス作りました。島でお会いても安心。そしてレガシーで打ち上げますよっていう打ち上げ方法もしっかり書かれていました。エキスパートがここにいらっしゃいますね。マルチメディア。ちなみになんだけどさ、リア自慢していい？イサのさ、アースオブザベーションアカウントにさ、フォローされてるね。やっぱ、アースケアの話したからかな。イサのアースオブザベーションのところにね、フォローされててびっくりした。ね。加速されてる。びっくりしたわ、本日で。ということで、応援してますので、今回も盛り上げていこうと思っておりました。はい。これなんかバイオマスです。ざっくりしていいかな？めちゃくちゃ詳しくさ、全部読み込んでもさ、わからんてーってなることもあるかなってちょっと思った。あと昨日ね、しんどいよって言ってたけど、体調はね、割と戻ったんだ。お腹が痛かったんだけど、変なもん食べたとかでもないよ。金沢で無理したわけでも、金沢はね、すっごく楽しくて、金沢で無理したわけではなくて、問題なかったんですけど、 そう、何個かね、見られなかったロケットがあって、昨日出られなかったライブと配信と、あと今朝のね、カイパーの打ち上げ、この間打ち上げなかったから、プロジェクトカイパー見たいなと思ってたら、寝てる間に飛んじゃって、起きようと思ってたのに、ミスったと思って。あとお昼にあったスターリンクの方は、まあ無理しないでおこうかなと思ってやってませんでした。ちょっと待った、大丈夫。リア、食べ物でお腹壊すのはあんまりないんだ。うん。でも腹痛いことはある。なんでなんだろうな。それお腹壊してるっていうのかな。ファイアフライ飛ばなかったね。そうだったね。油分が足りなかったのかなかもしれない。そっちかもしれない。油分が足りなかったのかもしれない。うん。変なまでお腹壊すってそういうことなのもしかして。お腹壊すってそういうこと分かってないな。けどもう少しで2回目の AVUM 燃焼があるっぽいので、はい、紹介しつつ、ここを見てほしかったのに、いっぱい見ましたね。あ、そうだ、フライトシーケンス見てないぞ。フライトシーケンスでん。リフトオフから始まり、2分後に T1020C 分離、4分30秒後にゼフィーロ分離、4分33秒後にフェアリング分離、7分でステージ3分離、8分で1回目の4段目の燃焼をして、その後、53分後に2回目の燃焼を行います。なので今はここですね、53分から57分が、あともう少しでやってくるんじゃないかなと思っています。3回目の燃焼は1時間46分って書いてるけど、これはね、もしかしたら配信ないかもしれませんね。この後落とすとかかもしれない。見るか。リプレイ。リプレイ。じゃーい。いやー、やっぱ固体ロケットは煙がいいですよね。かっこいい。そしてすぐね、今回は雲ジュボでしたけど、
Hello again and welcome back to our YouTube Live. We're coming to you from the European Spaceport in South America. We are 51 minutes into the launch of Biomass for the European Space Agency, and those images were the launch, which took place 51 minutes ago. We lifted off from the pad here at the spaceport, and right now Biomass, our very precious satellite, is hurtling through space, attached to what's left of the upper stage. I'm Katie Haswell, and joining me in the commentary box is Samuel Rogers. Samuel, great to have you with us. Thank you.
Thank you. Great to be back.
Yeah, Samuel is a real rocket science expert. We're very lucky to have him in the commentary box. Samuel, just run through what's happened for anyone who missed the beginning.
So we had the first phases of the flight were for the ignition of
Acquisition de la
the...
télémesure par la station Nunancia en Australie.
It's just letting us know that we've picked up the signal at the new Norcia tracking station in Australia, so we're checking in with the teams there.
So we had main steps were first stage burning, so P120.
De l'étage avant.
Then we had the second stage, Zefiro 40, for a bit more than 2 minutes, then the Zefiro 9 for 2 minutes and a half, and then the first boost of the Avon Plus upper stage over Canada, and we had a long pause over the North Pole without propulsion, and then we have just had contact with the New Norcia ground tracking station, and we'll be ready soon to fire the Avon Plus again for the second time.
You can see on the left-hand side those events. What's coming up and what's already happened, what's happened in blue, what's coming up in white, and our telemetry on the right-hand side of the screen. We've got some hot news from the Guyana Space Centre. The team's tested a new solid propellant rocket motor called the P160. That was a few days ago.
Yes, indeed, and it's a major milestone.
Début de la manœuvre d'orientation pour le deuxième boost à volume.
I will interrupt while he is speaking. It's a major milestone because it's a key development for future
Fin de la
upgrades
manœuvre d'orientation.
of both Ariane 6 and Vega, Europe's launchers. This new motor is 1 meter
Pression
longer
réservoir nominale.
than the P120, and it carries 14 tons additional propellant.
And we've got here the switching on,
Allumage confirmé de la
on of the upper stage, which has now been confirmed. And here's the picture. We can actually see the hot fire test there of the P160
Propulsion nominale, pilotage
firing
calme.
up.
And it's really key because it will increase the Ariane 6 and Vega performance, their payload capacity and their competitiveness. So really a very good complementary development for these.
Trajectoire du lanceur nominale.
He's telling us that the trajectory is normal, everything's going according to plan up there in space. We've had a question from somebody called X who is asking Samuel, why does the fourth stage burn for so long? Is it in orbit yet?
So yeah, we are in orbit, but not at the right altitude. So we are, in fact, we are in we are like in a roller coaster. So first we have picked up some speed thanks to the solid
D'écart en
boosters.
altitude, pression chambre nominale, trajectoire nominale.
Thanks to the solid boosters and the first AVUM burn, then for the first 16 minutes of the mission. And then at the end of this first boost, we were at the bottom of the roller coaster, starting moving up. And during the break, we have slowly lost speed, but we moved up to higher altitudes. And in physical terms, it means we have transformed the kinetic energy, meaning the speed, in potential energy, meaning altitude. So now we are close to reach the top of the roller coaster at
Il n'y a pas d'écart en
670
altitude, la trajectoire est nominale.
at 670 kilometer altitude. So it's the right time to fire again the upper stage. So in other words, we were in an elliptical orbit and we're waiting to get to the apogee. This is the highest altitude point to burn again the upper stage and circularize the orbit. This is the technical term for it.
So it's a
Propulsion
bit like
nominale,
we were at the top of the
trajectoire
roller coaster, and
nominale.
instead of coming back down, we just keep on flying.
Exactly, flat.
Slightly
To keep-
terrifying concept.
Extinction de la volume.
We've had the confirmation there that we've switched off the AVUM plus upper stage, so that's good news. Another very important moment. So as you say, we're
Orbite
on
atteinte par la
altitude.
volume correcte.
And this is precise, very important information. The
Début
orbit
de la
we
manœuvre d'orientation au profit de Biomass.
we have just reached is the right one. So now we're performing quite a set of maneuvers to orient the satellite plus what remains from the launcher to point the satellite into the right direction, the one required by the customer for biomass separation.
そろそろバイオマス分離だよ。
So it'll take 1 minute and a half, and then
Pilotage calme.
we'll be able to separate biomass by releasing the clamp band which was attaching the spacecraft to the black cone here, and then there are a number of springs that will gently push biomass away from the launcher.
We're effectively going to ping it into orbit so that it'll move away from the mothership. That's coming up in less than 30 seconds now. Very precise orientation maneuvers up there in space. These computer-generated images showing us exactly what's been planned for today's mission.
Fin de la manœuvre d'orientation.
So we have reached the end of the maneuver.
So we're getting ready now to separate biomass.
分離するよ。
Séparation biomasse.
Nice.
Merci Baton.
Confirmation there that we have separated the biomass satellite. This is wonderful news.
Great news.
Congratulations to all the teams, everybody involved.
Nous
This has
attendons
been
la confirmation de l'acquisition du signal du satellite.
He says we are now waiting for the confirmation of the acquisition of the signal of the satellite. That is, of course, when the satellite will talk to us.
Hello to
and say hello. It'll call home to the teams at the European Space Operations Centre who have now taken on their new baby. And we're hoping to hear now from the CEO of Arianespace, again, David Cavallolis, who spoke with us earlier. And look at those wonderful images there, the computer-generated images, the CGI animation of biomass. It looks like it's floating away, but it's actually travelling incredibly fast still, isn't it? It was 28,000 kilometres a second.
It's fast with respect to the ground, but it's slow with respect to the launcher. We want the separation to be gentle, not to have too high speeds to avoid any risk of collision. So it seems to be slow, but it's really fast with respect to the ground.
Teams here in the Mission Control Centre, everyone very, very delighted now that we have had the separation. So let's go over now to David Cavallolis, who joins us once again from the fishbowl. David, thanks ever so much for coming to talk to us. So good news.
Yeah, absolutely, Katie. I'm absolutely delighted to announce that today the Vega-C launcher, operated by Arianespace, has successfully placed into orbit its passenger, the Biomass satellite. I would like to very sincerely thank our client and partner, the European Space Agency. And today, with this launch, not only we reinforce the autonomous access to space for Europe, but also we contribute to make better life on Earth and to protect biodiversity. So this is really a huge achievement, and I would like to say a big, big congratulations to all the team involved. And thank you very much, and thank you to all our viewers all around the world.
Indeed, and it's a busy time here at the Space Launch, isn't it, David? Lots of launches. So, David, thank you very much indeed for coming to the floor and chatting with us. We wish you and the teams the very best of luck now for ongoing operations. David Cavallolis, thank you very much.
Thank you.
So, good news, Samuel, for good news there. We've separated our satellite, and we're now waiting for the Biomass satellite to call home and talk to us. And this is going to take a little while because we have to wait for the satellite to come over the horizon, I believe, and for the spacecraft controllers at the European Space Operations Centre, which is the European Space Agency's operations centre, their mission control, where they fly the satellites. Waiting to hear from them later in the programme. But first of all, I'm absolutely delighted. I've got somebody very special joining me here in the commentary box. She is the principal investigator, one of two principal investigators for the mission. Her name is Thuy Le Thuan. And Thuy, I am absolutely so happy that you've been able to come and talk to us. Thuy, before we talk about anything else, you must be absolutely delighted.
Okay, I feel so happy, and it's beyond words to see Biomass lift off.
And Thuy, I just realised that the mic wasn't switched on, so let's just start again. I just was saying you must be absolutely over the moon.
Yeah, but I feel so happy, and we beyond words to see Biomass lift off and now reaching its orbit. And I feel like people at the end of a long journey. Yeah. But it's not the end of the story, because it is the beginning of an exciting phase when the Biomass will deliver the first data, and the community will take in charge the data and transform them to useful information and making use of it. Yeah.
Yeah, absolutely. And it's not the end at all. I mean, it's the end for some, but very much the beginning now of Biomass's life. Your new baby, it's in space, going through its early stages before it can start its job. That will be in about 6 months' time, won't it? The commissioning phase takes about 6 months before it's ready. Listen, I tell you what, I thought might be interesting to ask you, before we talk about the satellite itself. The satellite's called Biomass.
Yeah.
But what actually is biomass, the organic matter?
Normally, the name should be forest satellite, for example. Yeah. But biomass is because we focus on the carbon content of the forest. Biomass is a proxy of carbon content. About 50% of biomass is carbon. Yeah, and why it's so important? Because it's the dry mass of the organic matters in the wood, and plants, as you have seen before, the plants absorb carbon dioxide from the atmosphere and transform it through photosynthesis into convert it into biomass. So the biomass is then a key information in the global carbon cycle, because the biomass density, which is the quantity of biomass per area, like we express it in tons per hectare or megagram per hectare, this density determines the amount of carbon emitted to the atmosphere by the forest when they are disturbed through burning, decay, degradation, etc. And then as the trees grow, they absorb atmospheric carbon, and then they increase the biomass. So we call we talk about the role of forest as a carbon sink to take over the...
Yes. Yeah. And how much of a problem is this? I mean, as you say, we've often hear about the forests actually emitting carbon dioxide rather than absorbing it. How much of a problem is that? Sorry, I'm just letting everybody know that the range operations manager is still calling out the various events, because of course the rocket itself is still going through its process.
止めた。私、翻訳要線すまない。音聞き取れるんだけどさ、何言ってるか分かることもあるんだけど、それを日本語にできない。あとさ、見てみんな、これさ、よく見てったらさ、実はさ、回ってたんだよね、これ。わかるかな？こう。くるくるくるくるくるくるくるって。めっちゃゆっくりだけど、回ってたんだよ、これ。バーベキューロールしてたん。多分だけど、熱くなんないようにかな。こう、向きがね。待ってね、くるくるくるくるくるくるくるくる回ってる。この回転何のためだろう？これね、太陽から一方向に熱が当たるとね、炙られるような感じで熱くなるから、それが、一方向に当たりすぎないように、全体をまんべんなく焼いてる。まんべんなく焼いてる。そうそう。ケバブみたいな感じでね。冷静な丸焼き。そうそう。なんでこれくるくるくるくるくるくるくるくるしてるのが見える。バーベキューロールですね。バーベキューロールっていうよりケバブロールだと思うんだけどね、ケバブロール。ね、ケバブっぽいよね、バーベキューっていうね。
Makes possible to
La trajectoire de la Voom est nominale.
Sun or towards the Earth, for instance, as planned. Z is for Zephyro. It's an Italian name for a type of wind, because I guess it's a bit windy when you're on board such a booster.
Look at that. Fantastic. We're seeing it. We're 3 minutes and 11 seconds into the launch, and we can still see it with our cameras, which is very exciting. So we've got clear skies here at the Guyana Space Center.
Amazing, yeah. Wow.
We had several weeks of rain, and suddenly it's been very clear and beautiful.
La trajectoire du lanceur est nominale.
He's telling us that the trajectory of the rocket is normal.
It's perfectly as planned.
And of course the fairing, which is where our satellite is encapsulated at this point, Samuel, is the nose cone, if you like. We saw it before
La
the launch.
trajectoire nominale le pilote.
Yeah, exactly. It basically protects biomass from a number of environments. First, of course, the Guyana launcher arrived actually by sea, as you can see, at the port of Kourou, and were then transported by road to the space center. The rocket is assembled step by step from several parts, which we call stages. Here you see the first stage, P120 booster, transported to the launch pad, and then we have the second stage here, which was hoisted and then assembled on the top of the first stage. The third stage, the Zefiro 9, is also lifted into the gantry and integrated on top of the two first stages. Then it was the upper stage, the Avon Plus, which arrived in its dedicated container. You can see it there. It's hoisted, unloaded, and then integrated onto the first stages. As for the satellite, Biomass arrived in French Guiana on the 7th of March, also by boat. A number of operations were carried out in autonomy for Biomass. Then it was filled with propellants, and you will see the special suits that we use for this operation. Here you see it on the movie. Then it was integrated on what we call the adapter, which is the structure which make the link between.
衛星のさ、あれかな。衛星にも燃料があるんだけど、その燃料もしかしたら危ない燃料を使っているのかもしれない。
In French Guiana on the 7th of March, also by boat. A number of operations were carried out in autonomy for Biomass. Then it was filled with propellants, and you will see the special suits that we use for this operation.
これ。何やってるのこれ。閉めてるな。140、42と100。全然サイズが違う数字の。何なんだろう。でも閉めてるな。これが閉めてるんじゃないのか。なんだ、バルブ
You see it on.
違うな、注入かこれ。抜いてるかなこれ。圧抜いてんだな。わかんないな。真空引きかなポンプミスミフレームみたいなのがあることだけわかる。これはなんだなんか注入してるっぽい感じがするね。右の燃料自体かな。いやー、難しい。これは何君は誰私はクリア。君は誰ミスミフレーム便利だよね。ね、ミスミのアルミフレーム超便利だよね。わかるミスミかなミスミじゃないか。さすがに。わからんけど。これ何のやつだろう ?2 って書いてるかあれ ?2 ですね、2。これはなんだなんか、やばい薬品を扱ってることはわかる。なんかね。それしかわかんないかも。リアもね、高圧ガスの知識はあるから、わかることもあるんだけど、車上に置いてあるものとかね。これはわかんないな。衛星さん、勉強しないと思った。
On the movie. Then it was integrated on what we call the adapter.
この後は、普通の服に着替えてるもんね。カメラじゃない、電気と、カメラじゃない、鏡と。
Which is the structure.
で、これを重ねていく作業ね。欄干部に重ねます。
Which make the link between the satellite
ここは普通だ。
and the launcher. This is the black cone you see on the screen. And then
あとは、ベアリングですかね。何これ
it was enveloped in the fairing.
UL2029 って書いてたおお ドラジンですかって。で、UL2029 って書いてた？マジで？
this huge
戻そう。どこ
for this operation. Here you see it on
どこにあ、書いてる！あ、これヒドラジンだヒドラジンです。ヒドラジンです。はーい。そうですね。正解です。ありました。正解、すごい！ありがとうございます。これ何なんですかっていうコメントはあるさ、なんか危険物の番号があるんですよ。危険物の輸送かな？国際的に決まってる番号があるはずで、国連のなんかそういう番号うん。国連のね、決めてる番号があって、危険物の、データシートとかに書いてあるのが、こういうナンバーが書いてあったりします。国連番号。ありがとう。調べてくれた？ありがとね。そうそう。で、ヒドラジ。2029はヒドラジ。ほんとだ、書いてある。ありがとう。ヒドラジンだった。みなみな。助かる。ありがとうございます。つまりこれはヒドラジンの重点作業ということですね。つまりね。宇宙服っぽいの着てるけど、このバイオマスのヒドラジンを入れている作業なんだ。この写真だけでさ、それ分かるとさ、すごい楽しくない？なんか、あ、これまるまるやってるところだって分かるっていう、この、ね。
on the movie. Then it was integrated on what we call the adapter, which is the structure.
こういうのも面白いな。さっき何だったんだろうな。
In French Guiana on the 7th of March, also by boat.
輸送して。
A number of operations were carried out in autonomy for biomass. Then it was filled with propellants, and you will see the special suits that we use for this operation. Here you see it on the movie. Then it
こんな感じか？
was integrated on what we call the adapter.
この人何してるんだろう？このさ、一個前のやつ。
And you will see the special suits that we use for this operation. Here you see it on the movie. Then it was integrated on what we call
何してんだろうな。ボタンがあるな、ボタンが。クレーンしてる人かな？釣ってる作業者なのかな？てか、このさ、リモコンすごくない？リモコンのためだけにさ、台があるんだけど。そういう感じ？これどう見てもリモコンだよね。安全キースイッチついてるし、危なそうなやつもあるし、緊急停止っぽいのもあるし。それが箱に挟まって箱についてる。配線も太いね。で、左側にある配線に繋がっていて。でもこの場合こういう風に見るとやっぱり、これを釣っている、この上の者たちなのかなってなっちゃうよね。すごいな。台にそれ専用のものが置いてある。あとこう左側ではしごに登ってる人もいて面白い。
the adapter, which is the
これ何してるかな？傷がないか見たりするのかな？シールとかは取らないだろうし。
structure which make the link between the satellite and the launcher. This is the black cone you see on the screen. And then it was enveloped in the fairing, this huge part you see. And what
キルスイッチ？わかんないけど、安全キースイッチならわかるかも。なんかそのプロプロって鍵がついてて外れそうな。
what we call the upper composite was the
卵みたいで可愛いよね、これ。一回こう絞られるタイプのフェアリング。
transferred into the launch pad.
こんな感じなんだ。
It was
これわかる？これ空調の設備ですよ、これ。衛星が、守られてるこのね、卵の中に、新鮮？綺麗？ なんて言えばいいんだろう。空調設備ですね。空気を送り込む。空気というかもしかしたら窒素かもしれないけど、わかんないけど。何送ってるかわかんないけど、エアコンみたいな、そういうやつ。うん。
Hoisted on the very top of
多分そうだと思う。これ空調だと思う。違うかな。で、もっとつなげるんだね、下と。
the launcher and then integrate
はい。こんな感じで上にもね、リングがあり。縦向きに組み立てていくっていうのも、すごく日本の H3 と似てますよね。
on the upper stage. Finally,
すごい。
we have, as we said, removed the gantry and
はい、
we
こ
have
んな感じでございました。皆さんありがとうございました。今日はなんかこれ以外に見るものあるかしら。とりあえずいっか。今はどうなってんだろう、配信。
this data is going to be, but of
まだお
course,
話ししてた。
I mean,
インタビューしてるっぽいな。この後はね、一番上のエンジンを落とすための燃焼があるっぽいんだけど。
we didn't just arrive here today. This mission has been a long time in preparation. It's a big project, and it must have been a challenge just to get here. Can you tell us something about how you, how the teams, of course?
That's the last 4 minutes. Coming up, just briefly, Samuel, what is that?
À tous de DDO. Attention pour la séquence finale lanceur.
Range Operations Manager.
But of course, you can see on your screens there the views of the flight control team that are getting ready to control biomass, to fly biomass. What's been happening over the last...
ここかな。
Acquisition de la télémesure Biomass.
So we've received the signal in Peru, and we're just waiting now for that confirmation from our flight director, Jose Morales, here at ESOC.
リンゴのやつ食べます。こんにゃくバター。凍らしてやろうかな。これかな、電波の映像って。
Hear from the flight director right now. The flight director, or possibly he's too excited by the telemetry that's coming in now. So let's listen just a couple of seconds.
Too exciting telemetry in coming out って言ってますね。なので、テレメトリが来たっぽいですよ。わーい、おめでとうございます。打ち上げ成功じゃ。じゃあ、打ち上げ見て。リア眠いから寝る。歌いたいな。なんかすごく歌いたい。ロケットも見たいんだけどさ。歌いたい。歌うさ、
À tous de DDO. Attention pour le décompte final.
また今度。今日するか？するってもいい。
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage P120. Décollage. Propulseur nominal, début du basculement. Propulseur nominal. Pilotage calme. Trajectoire nominale.
はい、こんな感じでした。 フランス語のカウントダウンいいよね。
Acquisition
しか
changeant.
知らないんだけどね。
Trajectoire toujours nominale.
Sunrise over the Amazon rainforest, and Biomass has started its journey, blazing a trail on
La
board the
trajectoire est
Vega-C
nominale, le
rocket
pilotage est calme.
on its quest to understand forests just like the one it's lifted off from, on its mission for Earth and for our future. We can hear it flying
amazing.
over the
Amazing pictures, and yeah, we can feel the the walls
shaking here
shaking, wow.
at the Jupiter Mission Control
Trajectoire
Center.
nominale.
He's telling us that everything is going well.
Yeah, so far it's perfect. We are lucky to see it so long. It's given the cloud we had at the beginning.
Getting some great views here from our cameras. Burning the P120 first stage here, which is getting us away from
La
the
trajectoire est
gravity,
nominale, le pilotage est calme.
the gravity of our planet. The range operations manager there telling us that the trajectory is nominal and the pilotage, the piloting,
Yeah, control of the thrust, the orientation of the thrust as well. So it's nominal means everything's fine.
good. Coming up
Début côte poussée.
on the separation of the P120 will be the first event.
La trajectoire est nominale.
Everything's going according to plan. Fantastic
Potentially,
views.
we could see it from the cameras. It could be nice. Yeah, should occur in a few seconds now.
このまま歌うなんかリア歌歌いたくなってきた。
Indeed, this is the scheduled moment for the
And you can
separation.
see it on the,
Séparation P120.
and it's just confirmed.
Allumage Z40.
So he's just confirmed that we've separated the
La pression est
P120,
nominale.
the
La
first
trajectoire est nominale.
stage. We've switched on the second stage, the Z40. Everything's going normally. And Z, what does that stand
Z
for?
is for Zephyro. It's an Italian name for a type of wind, because I guess it's a bit windy when you're on
Trajectoire du
board
lanceur nominale.
such a booster.
Look at that. Fantastic. We're seeing it. We're 3 minutes and 11
これなんだろうこれ。分離したやつかなこれ。分離したやつかやっぱ。
booster.
これ。
What does that stand
Z
for?
is for Zephyro. It's an Italian name for a type of wind, because I guess it's a bit windy when you're on
Trajectoire du
board
lanceur nominale.
such a booster.
これなんだろうやっぱ分離したやつかななんかさ、ずっといるんだけどこれ。
Look at that. Fantastic. We're seeing it. We're 3 minutes and 11 seconds into the launch, and we can still see it with our cameras, which is very exciting. So we've got clear skies here at the
はい、こんな感じでした。わー楽しかった。ということで、一旦終了します。はい、こちらは、フライト VV26 バイオマスレガシーの打ち上げでした。今日はカイパーの打ち上げもあったんだけど、見ることができなかったので、また今度見たいと思います。あと、朝鮮の打ち上げもね、最近見てなかったから。見たいよね。じゃあ、また今度やりましょう。今日はちょっと歌いたくなったんで歌を歌おうと思いますが、いいですか？もうね、このまま歌うわ。たくさんの人見てくれてるし。はい。なので、次の枠を決めたので、次の枠にぜひいらっしゃってください。お疲れ様でした。バイバイ。じゃあね。シュッ。終了。歌はですね、今完全に思いつきである。マジで。たまにはいいでしょ。はい。ではでは、次の枠まで行きましょう。This, no, need, set, sis, 3, キャ 3、2、1、0。デコラージュ。バイバイ。